We have this question in physics. The figure below shows a uniform wooden ruler of length 100 centimeters, pivoted at 25 centimeters, when weight of 5 newtons and 15 newtons are hung at 0 centimeters mark and 20 centimeters mark respectively. So we have the pivot, which is placed at 20 centimeters mark and is balancing when the two weights, the 5 newton and the 15 newtons, hang at 0 centimeters mark and at 20 centimeters mark respectively. The question is, determine the weight of a uniform wooden ruler. What are we going to do? The first thing is to identify. We can call this one W1, W2, and the distance from the 0 centimeters mark to the pivot. We can call this distance as D1, and this D1, 25 centimeters minus 0 centimeters is giving us 25 centimeters. Dividing that by 100, we have 0.25 meters. Now, the 15 centimeters, sorry, the 15 newtons mark, where it is at 20 centimeters mark to the pivot. What is this distance? Let's call it D2. This distance is 5 centimeters. 25 centimeters minus 20 centimeters is giving us 5 centimeters. And in meters, we divide it by 100, it's giving us 0.05 meters. Okay? Now, we are requested to determine the weight of the uniform wooden ruler. Meaning, we are told that this wooden ruler is uniform. Meaning, its mass is concentrated at its center. If this is the center of the uniform wooden ruler, then all its weight is concentrated at the center. So, what is the distance from the center of the ruler to where the pivot is? We can call it D, okay? And subtract, what is the half of 100 is 50. So, the weight of the ruler is concentrated at 50 centimeters mark. So the difference, 50 centimeters minus 25 centimeters is giving us 25 centimeters. Dividing by 100 is giving us 0.25 meters. Now, using the principle of moment, the sum of clockwise moment about the pivot must be equal to the sum of anti-clockwise moment about the same point. Which same point? The pivot. So, according to the principle of moment, we will say W times D is equal to W1 G1 plus W2 D2. Remember, all these weights are creating what we call anti-clockwise moment, anti-clockwise rotation. And this weight concentrated at the center is creating what we call clockwise. So now, we have that W, our D is 0.25 meters, is equal to our W1 is 5 newtons times that distance 0.25 meters plus W2 is 15, okay, 15 newtons times the distance, which is 0.05 meters. Now, when we do the computation, we'll have 0.25 meters times W is equal to if we are to use a calculator, we have 5 times 0.25. It's giving us 1.25 Newton meter. Okay, plus the 15 newtons times 0.05 is giving us 0.75 Newton meter. Adding the two, that is 1.25 plus 0.75, giving us 2 Newton meter. And dividing throughout on both sides of the equation by 0.25 meters, 0.25 meters, we remain with W there, and 2 dividing by 0.25 is giving us 8 newtons. Okay, this is how we solve the equation.